Hello students, how are you? Today we try to simplify problems on differentiability in a best method. Let's try. At x is equal to a, let us consider h of x is equal to f of x plus g of x. These are two functions. F of x is equal to h of x plus g of x. Suppose if f of x is a differentiable function at x is equal to a and g of x is also differentiable function, ultimately what happens, differentiable plus or minus sum of two differentiable functions or difference of two differentiable functions always a differentiable function. No need to check at that point using any formula, just we can simply using this formula we can simply say, suppose if h of x is equal to f of x into g of x, the product of two functions. If it is a differentiable, if it is also differentiable, then their product is also differentiable function. In a short manner we can declare that it is also differentiable function. Suppose if h of x is equal to sum f of x by g of x, and if it is f of x is a differentiable function at x is equal to a and g of x is also differentiable function at x is equal to a, if these two are differentiable functions, then h of x is also differentiable function. Suppose in this case g of a should not be equal to 0, that condition should satisfy. So this is about differentiability of two functions. Sum, product or division of two differentiable functions always a differentiable function. Suppose in other case 2, if you consider case 2, if h of x is equal to f of x plus or minus g of x, suppose if it is a differentiable function, f of x is a differentiable function, g of x is not a differentiable function, if it happens, then what happens? Then the resulting function h of x is also non-differentiable function. F of x plus g of x, f of x minus g of x, or if both are differentiable and non-differentiable functions combination, then the resulting function is not a differentiable function in this case. Suppose if f of x is not differentiable function and g of x is a not differentiable function, otherwise if h of x is equal to f of x into g of x, f of x into g of x, f of x is a differentiable and g of x is a non-differentiable function, or f of x is a non-differentiable function and g of x is a non-differentiable function. In all these cases we cannot say directly whether the resulting function h of x is a differentiable or not differentiable. Non-differentiable plus or minus non-differentiable, or non-differentiable into differentiable, non-differentiable into non-differentiable. The product of two functions, differentiable and non-differentiable, or non-differentiable into non-differentiable, and non-differentiable plus or minus non-differentiable cannot be declared directly. But what can you declare? F of x plus g of x, f of x plus g of x, or plus f of x minus g of x can be determined directly. Okay. Also we notice that second point, let us say this is point 1, first point. So if you consider a differentiable function of a differentiable function, always a differentiable function, the composite function, and differentiable of non-differentiable or non-differentiable function of a differentiable function at point x is equal to a, all these at a particular point we are discussing, or Non-differentiable of non-differentiable function cannot be said directly whether it is differentiable or non-differentiable. Nothing can be said without verification. Nothing can be said directly in this case. So using the formulas, using the rules of whatever I have learned, let's try to solve some problems. Here f of x is equal to sin x plus x cube plus 3x square plus 4. If you observe here, sin x plus x cube plus 3x square plus 4, these are two functions. So in sin x is f of x and h of x and some g of x. It is differentiable function everywhere as it is a smooth curve, and this is a polynomial curve. It is always differentiable on R. It is differentiable on R, differentiable on R, and differentiable on R. This is also sum of two differentiable function is also differentiable function. Therefore the resulting function is differentiable on R. So that is f of x is differentiable on R. This is the first example. Let's try the second example. Suppose the function is, let us consider cot inverse x. G of x is equal to cot inverse x plus some 2 power x. That is also differentiable plus a differentiable, means the resulting function is also differentiable function. Suppose if you consider ln of x into ln of x divided by sin x, what can you say about this on R plus? Differentiability, check the differentiability on R plus. If you see, ln of x is differentiable on R plus. Ln of x is a continuous function in its domain. It is differentiable on R plus, on positive numbers, because at 0 on negative integers, negative real numbers, it is not differentiable, and sin x is differentiable everywhere on R. Therefore the resulting function g of x is equal to ln of x by sin x is also differentiable. That implies g of x is differentiable function. It is a differentiable function on R plus, because ln of x is a differentiable on R. So hence it is a differentiable function on R. Therefore g of x is differentiable function on R plus. Why? It is the domain, common domain is positive real numbers. Next, suppose if we consider some other example, let's say f of x is equal to some modulus of x into tan inverse of x. If you consider this function, discuss about the differentiability of this function. We know that box x. What about the graph of mod x? Mod x is V-shaped graph. At the origin, it is not differentiable. And tan inverse x is differentiable everywhere because it is a smooth curve. Tan inverse of x minus pi by 2 and plus pi by 2. Between minus pi by 2 and plus pi by 2, it is a smooth curve. Therefore, it is differentiable on R plus. What about modulus of x? It is not differentiable on at x is equal to 0. It is not differentiable at x is equal to 0. So we need to discuss about the discontinuity of this function. We know that for all x belongs to R minus 0, for all x belongs to R minus 0, modulus of x is differentiable. Modulus of x is differentiable. And tan inverse x is differentiable for R minus 0. It is differentiable everywhere. In particular, R minus 0, it is a differentiable. Differentiable plus a differentiable, the resulting function is also differentiable function. Understanding? So what is happening here? The resulting function mod x plus tan inverse of x is also differentiable function. It is a differentiable function. It is also differentiable function on r minus 0. So differentiable plus differentiable, again differentiable function. Suppose if you observe at x is equal to 0, what can you say about at x is equal to 0? It is a non-differentiable function. Box x, mod x is not differentiable function. Plus, what about tan inverse x? Tan inverse x is differentiable everywhere. So one is non-differentiable, other one is differentiable. We already conclude that. We already stated before. Non-differentiable plus differentiable, always non-differentiable function. So what is non-differentiable function here? Here the non-differentiable function is mod x plus tan inverse x. So what can you conclude? Mod x plus tan inverse of x, mod x plus tan inverse x is not differentiable yet x is equal to 0. Therefore it is differentiable, and it is differentiable for all x belongs to r minus 0. This is the required result. See this example, x minus 5 plus signum of x. This is in the form of f of x plus g of x. We know that the graph of x minus 5 at x is equal to 5, it is V-shaped curve. It is not differentiable. Graph of y is equal to modulus of x minus 5. If you see this graph, it is V-shaped graph at x is equal to 5. What about signum function? Signum function is not differentiable at x is equal to 0. We know the graph of a signum function at x is equal to 0, 0. At x is equal to x greater than 0, it is equal to x. For x less than 0, it is also minus x. It is the graph. At x is equal to 0, it is not differentiable. So it is not differentiable at x is equal to 0, it is not differentiable. Sorry. At x is equal to 0, signum of x is not differentiable. It is differentiable. But at x is equal to 5, it is not differentiable. Signum function is differentiable. For signum function, the problem is at x is equal to 0. For y is equal to modulus of x minus 5, what is the problem? Where it has a not differentiability? At x is equal to 5. Now we need to find out the differentiability of this total function, composite function. Therefore, we need to check at x is equal to 5 first. At x is equal to 5, what about this curve? It is not differentiable. At x is equal to 5, what is a signum function? It is a horizontal line. It is a continuous. It is a differentiable. Therefore, it is a differentiable function at x is equal to 5. And what can you say about at x is equal to 0? At x is equal to 0, this function modulus of x minus 5 is differentiable function. It is a differentiable function, modulus of x minus 5. What about signum x minus signum of x? It is not differentiable because it is not continuous even. Every discontinuous function is not differentiable function. So differentiable plus not differentiable plus differentiable function. Therefore, for x, in all the cases except these cases, not differentiable plus differentiable, not differentiable, differentiable plus not differentiable is also not differentiable. If one of them is not differentiable, then it should not be differentiable. For x is equal to 0, 5, f of x is equal to modulus of x minus 5 plus signum of x. Signum of x is not differentiable. But what is a differentiable? For all real numbers it is differentiable except these two numbers, because for for all the real numbers x minus 5 will be differentiable, and except x is equal to 5 it is differentiable. Therefore, hence we conclude that the function f of x, the function is differentiable for all x belongs to r minus, what is that, 0 comma 5. So in this, at these points the function is not differentiable at 0 and 5. Except these 2 points it is differentiable, the given function is differentiable everywhere. See, let's do some other problem. Modulus of x into tan inverse of x. What can I say about this? If you see, modulus of x is not differentiable at x is equal to 0. So at x is equal to 0, it is not differentiable. It is tan inverse of x. Tan inverse x is a differentiable on R. It is a differentiable on R. So here not differentiable into differentiable. What can you say? From the basic definition, non-differentiable into differentiable cannot be determined directly. Non-differentiable into differentiable cannot be determined directly. But determinant into differentiable function into differentiable function is differentiable. Differentiable plus or minus differentiable is differentiable. Non-differentiable plus or minus differentiable is non-different. You notice one thing, non-differentiable plus or minus, containing plus or minus, differentiable is non-differentiable. Non-differentiable plus or minus a differentiable is non-differentiable. Non-differentiable into differentiable function cannot be said directly. So it should be verified using the differentiability formula. So now we check differentiability yet x is equal to 0. Except x is equal to 0 at all the real numbers. For all the real numbers it is differentiable, it is also differentiable. It is a polynomial function everywhere except x is equal to 0. At that point only it is containing V-shaped curve. So whenever we get a kink, that means V-shaped curve, it is not differentiable because it is at that point it contains 2 different tangents. Therefore it is not differentiable. Now check the differentiability at x is equal to 0 using the formula. So f dash of 0 we need to find out is equal to limit h tends to 0 or x tends to a from the first formula, f of x minus f of 0 by x minus 0 is the fundamental formula. This is fundamental formula, that is equal to limit h tends to x tends to a, x tends to a means here 0, at x is equal to 0 we are finding, x tends to 0, f of x means what, x into tan inverse of x, modulus of x into tan inverse of x minus f of 0. If you keep 0 in the given function, 0 into tan inverse of 0, 0, that is equal to 0, f of 0, 0 by x minus 0, x. So we need to find out f dash of x as it is containing a modulus of x. So whenever x approaches to 0, modulus of x what? What about modulus of x? Modulus of x is kink. So whenever it is approaching 0 from either side, modulus of x approaching 0. From the left side, if it is approaching 0, modulus of x, the curve approaching to 0. So in this case it is approaching to 0. Tan inverse of x by, we know that limit x tends to 0, tan inverse of x by x is equal to 1. Therefore, it is 0 into 1. That implies 0 into 1 is equal to 0. Therefore, finally we get f dash of 0 is equal to 0. Whenever we get this result, immediately we think of here as it is getting some definite value, we can say that f dash of 0 is equal to 0 and f of x is differentiable function at x is equal to 0. Already we declared that it is differentiable everywhere. Therefore, f of x is differentiable on R.